Yeah, welcome to our talk about a migration project we did some months ago from Eclipse PDE to Bndtools. Just for my curiosity, who is using Eclipse PDE? And who's using Eclipse Bndtools? Oh, less. Okay, less opportunity. Short introduction to ourselves. My name is Jochen. I'm working for Deutsche Telekom, working as an evangelist, architect for the software running on our smart home gateways. Amit is one of our experienced OSGi developers, also commuter on Kumar project here on Eclipse, and he mainly did the work. So he's the guy behind everything. Just about some introduction words. What is QIVICON? QIVICON is a general product we developed at Deutsche Telekom for the smart home space. So we started to ship the product in 2013, so it's 5 years ago now. It's based like a lot of other smart home gateways. Typically, we're starting from OS Linux. We're running Java SE, Java SE embedded in an optimized version. We have multiple gateways now supported. We're running either Compact 3 or, in unfortunately a few cases, Compact 2 profile. We're running an OSGi framework, ASZ, on a very outdated 4.2, which is surprisingly not the biggest problem, but it also some challenges, especially if you want to use the newer services. We're running on top of that Eclipse SmartHome since 3 years now, I think. So together with our colleagues who are doing development for Eclipse SmartHome, we introduced the stack also in our commercial product. So a lot of device integrations are coming from the open source stack. Just see maybe here some insights. We're not using all of the components, but I would say now about 60% of the open source components also in our commercial product. On top of the open source stack, we're running our own application logic, which consists of additional security stuff, streaming for cameras, and a lot of other stuff. Our own device integration, so called the proprietary bindings for that one. And on top of the platform, then we offer the opportunity to host partner applications. So we, Deutsche Telekom, provide our own end customer application, but we can also provide a platform that our partners can also provide their own application and customer logic and let it manage and install by ourselves for the whole customer base. That's more or less the short introduction about the commercial product. Maybe just to give you some numbers about how much code we're talking about that. For the QIVICON space, we just handle about 300 plus bundles, including test bundles or test fragments mainly. It's just about the code which belongs to us and which will be maintained by us. In addition to that, we have from the framework itself, let's say about 50, 60 bundles, partly in the firmware, partly downloaded from our management system. We have the Eclipse SmartHome, also about, let's say, 50, 60 bundles, which have been provided by the open source. So we're delivering the binary artifacts on that one. So overall, it's a more complex environment where we get it from different sources, suppliers, open source projects, artifacts, which go into our commercial product. We have at the moment about 20 up to 25 people, developers, using that kind of development environment, using the CI/CD chain. So it's, at least for us, a relevant number of people involved on that one. Let's look a bit back about what does PDE offer, or where we saw in the past the major pain points. So on the dependency management side, mainly PDE is using the target file, where we define more or less everything which we compile again and run again. Run again is in our case a little bit twofold, because we run, as part of our test cases, some stuff on the software side running locally on our development machines and our CI system. And we also run parts of our test cases also on the target environment. So really on our smart home gateways, where we can run the test cases against that. So we have sometimes part of open source OSGi frameworks as part of our IDE and CI chain, and also some parts which runs against the real target hardware. Overall, because as I said, we consume a lot of different artifacts from different repositories, we at the moment stick with a complete P2 Maven Tycho based build process. So we consume mainly P2 artifacts. And at the end, we have a lot of distributed repositories for the core part, for extensions, for bindings, for other stuff. So everything comes together then, sharing the artifacts in the Nexus repository. And it turned out that the overall process is very, very complex. And sometimes we have errors that some artifacts have not the right version uploaded. So it's highly automated, but in case that something does not work, you always have to struggle around and see what's going on here, what's in the repos, and so on. So that's something which really makes us some work. The other point, which from my point of view as an architect also annoys us, because we have the target platform, we have a lot of artifacts available on that one. It happens from time to time that developers just use a functionality, just get me an import for that kind of tooling, and then we run at the end with additional bundles added to the system. At build time, everything is fine. Then we go to ship that, and we see, oh, that's a bundle which takes about 200 kilobytes, and we don't want to do that because our smart home gateways have restricted resources. We have to care about memory usage. We have to care about flash memory usage. So I am, as an architect, always try to keep the platform as small as possible. And sometimes just during development phase, artifacts came into the platform which we do not like that. As PDE is in general manifest first based, we have to maintain them by the PDE tooling. We use, not for all of them, we use in parts of that semantic versioning, which means we have to maintain them manually, which can be done, not very nice, and error prone. So we came over problems on that one, that the versioning was not exactly, we forgot something. If you just have 300 plus bundles, a lot of people are working in parallel, so something just happens. We make code reviews, so we try to find that, but at the end, sometimes we really have problems from that one. In addition to the manifest, we started at the beginning, fortunately, using declarative service as our, let's say, main development paradigm. But 2011, we handcrafted the XML files manually, which is now totally more comfortable using annotation-based development approach. But we have a lot of stuff which was existing XML stuff describing our components and so on. We're also using, in parts, meta-type, because we have user interfaces where we configure services. So meta-type is also something we use on a regular basis, and also maintain these meta-types in handcrafted files. So this is also a little bit annoying, because we could do a lot of better stuff by just generating these artifacts. On the one side, we don't start the runtime directly from IDE side, because we're running typically against a gateway, a real gateway. Could be either in software, so we have emulations on that one, or could a real gateway. So, but for running test cases, the developers always complain, because for some reason it was not totally reliable to run the same test case on different machines. Always we struggled around that. These have been just an excerpt of the main pain points we faced over the years, and we want to do it better. So what was our goals doing this kind of migration step, which takes us really some effort on that? The one thing is, we want definitely have a better view in the dependency management. And Bndtools allows something about viewing your artifacts in a better way. So we want to also have explicit control what is part of your target platform. So I want to be informed if someone would like to get a new bundle installed on the runtime side, because that's something we have to do very carefully, think twice about it, think about the footprint, think about dependencies we introduce, and so on. So dependency management is really one of our key stuff. We definitely want to be better than in the past. As I just said, we're using DS as our first principle on software development design. Follow in general the idea of API separation from implementation, maybe not in all cases, evolved over a lot of years, the system. But we want to make this kind of approach, separating between API and implementation, also one of our first choice design principles. And we want to have a tooling which definitely helps us better on that one. Also, one stuff we want to enforce is about use semantic versioning in all of the places. That's something we also have to align with Eclipse SmartHome project, because at the moment the project itself doesn't use semantic versioning at all. So if we try to do our best on our side, it only solves some problems, but not all of the problems. But at least for the own code base, which is completely under our maintenance and control, we can do that. And we definitely want to know better if we do break any APIs, or if we have to do some migration on some internal API involvement. As I also said, we started with the DS and handcrafted files. We definitely want to do the step, go into more annotation-based development, because this is also very error-prone. A lot of stuff have to be done manually. So we want to use now all these new modern features, like just writing your Java code, using annotations on that one. This is also something where we definitely want to get a better maturity and maintainability of the whole system. It's also one of our big goals on that one. And the last one, we just added a lot of developers in the last 2 years to our development group, and setting up the Eclipse PDE workspace from different repositories and target platform is always a lot of work and was not really reliable. Even if we try to use some installers like we just mimicked and copied some stuff from the Eclipse SmartHome open source project. But at the end, it was not so easy to set it up, so all the developers struggle a little bit. So we also want to have it much more simpler, and we also decided to use more or less a single workspace where we put the whole code base together in one single place. That's also one of our goals been. Yes, so I will hand over now to my colleague Amit, who is giving more details about the comparison to Bndtools and also give a short live demo how the migration process does work.
Yeah, thanks Jochen for introducing me and for sharing the motivation for the migration. Now I'd like to take the opportunity to talk about the noteworthy comparisons between PDE and Bndtools. Let's have a look. So if you are accustomed to PDE, then you know that you have to explicitly add all the packages to the bundle manifest, and which is really cumbersome. Whereas in Bndtools, you don't have to add the packages at all. You can do it, but it's optional. You just specify the bundles, and Bndtools generates all the necessary packages for you. Next, we have the instant jar creation. So if you make any change to any of the existing projects in PDE, then you have the possibility to build it with build tools like Maven, Gradle, so that the changes become part of the bundle. Whereas in Bndtools, if you make any change to any of the existing projects, then the jar is instantly generated, which is really handy for the developers to develop features pretty easily. Next, we have the default annotation support. So default annotation support in PDE is kind of yes and no both. Since in PDE, we have the DS or declarative services annotation support, but you still don't have the other build time annotation support, like let's say the meta type annotations and others as well. On the other hand, these build time annotations are by default processed in Bndtools. Next, we have the automated semantic versioning. Since in PDE, you have to explicitly add all the packages to the bundle manifest, you also have to specify all the versions explicitly, which is really error prone. Since in Bndtools, you're not adding or you're not explicitly adding the packages, you just specifying the bundles. Bndtools generates the headers, like not only headers, the packages as well as the versions together. Next, one project multi-bundles. So sometimes you have the requirement to group multiple bundles together in one project. That works pretty similarly. But in PDE, one project actually responsible for generating only one target artifact, whereas you cannot achieve this in PDE. But in Bndtools, you can group multiple bundles together in one project, and that project will be responsible for generating multiple bundles as target artifacts. Okay, now default OBR-based management. Okay, OBR stands for OSGi bundle repository. That actually aggregates the bundle metadata. And the primary goal of OBR is to simplify deploying and using the available bundles. So such OBR-based management is actually missing in PDEs. It's not supported by default. Whereas in Bndtools, it's actually supported by default, since all the repositories that you use in Bndtools, they actually support OBR. And in QIVICON, we are actually using OBR for cloud deployments. So that's why it's kind of notable thing that we encountered in using Bndtools. Okay, moving on, we have automated header generation. So in PDE, you have to explicitly add all the headers to the bundle manifest so that they become part of the final artifact, target artifact. In Bndtools, you can leave the BND descriptor almost empty, and Bndtools generates all the required headers for you as well. which is also pretty awesome for the developers to work on it. Next, okay, nested workspace structure. This is something about PDE that I really like, that you can have a nested workspace structure, you can maintain it, you can have your projects anywhere and import them in your Eclipse IDE and then work on it. But in Bndtools, you cannot have a nested workspace structure, since Bndtools enforces a complete flat structured workspace, which sometimes people feel like it's not worth it, and depends on the scenario, depends on the requirement that you have. Finally, the custom project template support. Okay, sometimes a project enforces like a proper nomenclature or naming convention of packages. Probably you need a file to be present in all the bundles. So this kind of things actually belong to the templates, and such templating support you don't have in PDE. Whereas in Bndtools, you can introduce your own template, enforcing lots of other things that you actually require for your project. It actually comes really handy to the developers to develop bundles that conform to the project standards. Okay, moving on. So before we delve deep into the demo, I think we should be acquainted with the terminologies involved in Bndtools first. Yeah, since Jochen asked at the early stage that how many of you are actually working on PDE and Bndtools, I think it's the right time to know about Bndtools, some basics. Okay, the first thing first. We have to know what a workspace is. A workspace is just a directory containing subdirectories, and all the subdirectories that we have, they are actually named according to the bundle symbolic names. So that means that in the workspace you have all the projects in a flat structured way. A workspace is completely valid if you just have a CNF file and you specify all your workspace specific configurations in this file. But the advised model is to have a CNF directory that comprises a build.bnd file, and in this build.bnd file you add or specify all the required configurations that you need for your project. But what do you have to configure in the workspace? In the workspace, you primarily configure the repositories, and we actually use repositories to consume artifacts or dependencies that your project needs. In Bndtools, we have several different types or integrations of repositories, but in QIVICON we just use some. The first one that we used is the P2 repository plugin, which has been introduced in Bndtools 3.3 pretty earlier. But how does it look actually? It's actually as simple as it is shown here. You just have to specify a name for the identification and the URL, where you specify the your URL, from where you actually need to consume the artifacts. Once you specify this URL, all the available bundles, all the bundles available in this P2 repos, they will be eligible for indexing in Bndtools. You might be wondering, why do we have to use P2 repos when we are switching from PDE to Bndtools? So the open source projects that QIVICON actually uses underneath, they are still based on PDE. So they are only available in P2 repos. So that's the reason we have to use P2 repos now. In addition to P2 repos, we also have used the Maven BND repository plugin. It's kind of full-blown interface for the Maven repos, Maven-based repos like Nexus, Artifactories, and whatnot. But how does it look actually? It's also pretty simple. You have to provide the snapshot URL, the release URL. You can also provide, specify whether you need to consume composite archives like zip, par here, and you have to specify an index file. That index file will comprise all the dependencies that you need. But how does this index file look like? Is it really scary? Not at all. It's also pretty simple. You have to provide the Maven coordinates, the group ID, artifact ID, and the version. You can also optionally provide the extensions. Here you see the zip file, and here you see the path. So once you provide the extensions, the composite archives, then the bundles which are actually contained in this composite archives, they will be eligible for indexing in Bndtools. Okay, moving on. What else do you have to configure in the workspace? You can configure, for example, the project directory layout structure. So this is the directory layout structure that we have used in QIVICON, and this is the same one that also Maven recommends. Apart from it, You can also specify like Java specific configurations, the source level, compliance level. You can also specify whether you need sources to be packaged inside the final artifact or not, up to you. If you want BND to process your DS or meta-type annotations, you can also specify that, and the minimum versions as well. I really would like to suggest you to have a look at the instruction list at this Bndtools website, and then you can decide on which instruction would be really good for your project. Moving on. So this is pretty much about the basics that you have to know before you make a switch. But what exactly do you need for the conversion? For the conversion, you actually need a control file and the BND library. So the control file is pretty simple. You just have to list all the PDE projects that have to be converted to the BND compatible project or Bndtools compatible project. You can also provide the different instructions like working set, if you want to group them together in one working set. You can also specify build path, test path, and many other instructions. Apart from it, you also need the BND library, and you have to execute the Eclipse PDE command. You have to provide the workspace here, the Bndtools workspace directory.
This is not in the main
Yeah.
rounds yet.
I think on that point here, special kudos to Peter Queens, who
Yeah.
did help us during these kind of migration. And this kind of PDE command was developed during our cooperation. So this definitely helped us to do that kind of migration. And it seems out to be a very useful tool.
Yeah.
So I think Peter is going to share that somehow, get in a more stable phase.
It will become part of the main branch, but I made so many changes that without merging it, it's a bit convertible.
But we use that tooling since, I think, June, July. So at least for us, it's now stable.
Yeah.
It worked well.
Pretty stable.
Yeah.
Okay, moving on. You also have to provide the instruction file, the control file. This is the one that we have prepared. And you can also specify whether you need BND to recursively search for PDE projects inside your inside the PDE workspace directory. So if you execute the command, then BND actually first tries to find the project, locate the project. Once it is located, it also tries to extract the bundle symbolic name. Once the bundle symbolic name has been extracted, it creates a project, a directory inside your Bndtools workspace directory after copying all the sources and resources from the PDE project. So that means in the Bndtools workspace directory, you'll get to find the BND projects with all the sources that you had in PDE as well. So what happens in the post conversion? The post conversion, you get to see the project in your Bndtools workspace directory. And every project will contain a BND descriptor. This is a bnd.bnd file that comprises list of instructions, and all these instructions will be automatically generated. The first one that you see here, let me show you, this minus manifest. This one actually tells BND to use the PDE's manifest. So the final target artifact that would be generated by BND would use the manifest from PDE. So far, the choice of using this manifest, the PDE's manifest, is not configurable, but we have already informed Peter to have it configurable in the final version. Okay, so this is pretty much about everything. So we actually have all the ingredients at our disposal to see how it actually works in practice. Let's have a look at the PDE projects that we'll be converting now. So for the sake of simplicity, I have created two projects, the API project and the implementation project. And it's also very simple. The API one just comprises one sample interface, sample service. And if you get inside the implementation project, then you'll see the sample provider. It implements the sample service. It uses DS annotations as well, which is processed. It can be processed in PDE by default. We also use the meta-type annotations for configuration support, which cannot be processed in PDE by default. You need build integrations. So this is pretty much about the PDE projects that have to be converted to the BND compatible projects. So for the conversion, what exactly we need now? We need a Bndtools workspace. I have created the Bndtools workspace that contains the CNF directory, contains the build.bnd file. So these are the configurations that I need for the projects right now to be converted to BND compatible projects. The first few lines it says, yeah, it actually instructs BND to use the source and compliance level. Different configurations like do not copy and sources. I don't want sources to be packaged inside the target artifacts. I also want BND to process my DS and metadata annotations as well. And this here is, this is the project layout structure. This is what QIVICON uses and what Maven also recommends. And finally, we have this Maven BND repository plugin integration. So this actually consumes all the artifacts from Maven Central. And you need to specify the index file. The index file is also pretty simple. It only lists 3 dependencies: the versioning, the DS annotations, and the metatype annotations. So for the PD projects to be resolved in my Bndtools workspace, I just need 3 dependencies right now because it's pretty simple. Once you have everything configured correctly, then you see in the repositories view there, all the bundles that I have listed here, they are indexed properly. So that shows that the dependencies are configured and are also indexed properly in Bndtools. They are ready to be used. Okay, now we also need, for the conversion, we also need a control file. How does that look? Let me make it big. Yeah, I've listed all the projects that have to be converted to the BND compatible projects, and I also use the working set so that I can group them together in a single working set. This actually happens automatically. If you do it, then all the workspaces are created automatically and the projects are grouped together. Okay, and the final one that we need is to execute the jar, the BND lib, the Eclipse PDE command. You have to specify the Bndtools workspace directory. You see here, sample Bndtools is my workspace directory, and here I have specified the control.bnd file. The sample PDE, where the project right now, all the projects actually reside in, and I want BND to look for projects recursively until it finds something. If I execute it, then you see that BND actually first tries to process it. Once it actually tries to locate it. Once it locates the project, it tries to extract the bundle symbolic name. And once it is extracted, it creates a project inside the Bndtools workspace directory after copying the sources and resources from the PD project. So if I go to Bndtools workspace right now and if I try to import them, then first you would find the 2 new projects, API and the provider. They are also used as a symbolic names. If I click on finish, then you see that they are green. That shows that they can resolve all the dependencies they actually require. If I get into the provider project and open this BND descriptor, it comprises this instruction that shows that it will use its PD's manifest, but if you don't need it, just remove it and just save. Now everything would be generated automatically by BND. And as I informed earlier, that once you make any change to any of the existing projects, then the jar is instantly generated. And if you get into the target folder, you see that there is the jar present. Click on it, and you see that the headers are generated automatically. And since we are using the DS and metatype annotations, we already instructed BND to process them. Then you see that OSGi inf directory is automatically created, and it also has this DSXML, generated DSXML. We are also using metatype, and the metatype also is processed, annotations are processed, and the XMLs are generated also. So you see, this is how actually Bndtools takes all the nitty-gritty pains from the developer's chest. And even though this demo actually involved only 2 small projects, it actually gives you an overview of how to execute such kind of migration. Jumping back to the presentation. Yeah, kind of off-quoted that if you have a clear vision with distinct plans, could give you tremendous feeling of confidence. So having said that, let's move on to discussing about how we planned it. So we started off with the migration in April with the ideation phase, where we planned the migration properly. Then we moved on to the research and analysis phase, And we started analyzing different projects from different teams so that we can group them together, have them together in a single workspace. And we also started setting up the different workspace and setting up the different repositories as well. We created repositories by separating the build time artifacts from the runtime artifacts. Once the workspace has been done properly, then we moved on to the migration trials. So here we executed different scripts, we prepared the control file, and until we actually have all the PD projects converted to the BND compatible projects. Then the next step was to integrate the Bndtools workspace with the existing system. The previous PDE build actually generated lots of composite artifacts which were subject to production deployment. So we kind of needed the same artifacts to be generated from the Bndtools workspace. So we are also striving really hard to find solutions. Once the solutions have been finalized, we set a proper migration milestone, and we didn't have a specific date though, we had the month only. And we also wanted to have a dry run to make sure that all the artifacts generated from the Bndtools workspace, they are also working properly on the home bases or on the gateways. Once the dry run was successful, then finally we did the final migration in early September. So even though we did the final migration, we kind of took around 2 weeks more to have the developers acquainted with the system, current system. And you see that for this kind of migration, we actually took around 6 months. So you actually need to prepare properly, or you need to invest your time properly to have or perform such kind of migration. So this actually brings us to the next question. What were the challenges? The first and the foremost challenge that we encounter is to have a stable environment in Windows. Due to some real indexing problem, actually Bndtools works a bit slower on Windows. So does Gradle. Next, the complex infrastructure. QIVICON uses a real complex infrastructure. It has their own, our own hosted repositories. We use different advanced constraints or advanced features from Maven to consume those artifacts from our own hosted repos. We also use client certificates, but unfortunately, BND does not support client certificates, or it does not support the advanced Maven features as well. So we kind of needed tweaks to consume artifacts from our hosted repos, but it works now. Next, integration testing. It's kind of common practice in PD world to consume or to write integration test in fragments. It's really common practice. But unfortunately, BND utterly ignores fragments. And that's why we kind of utterly ignored fragments. That's why we kind of needed an advanced support so that we can deal with fragments. And thanks to Peter for supporting us with that extension. Next, we have the multi-project sync. Since QIVICON is based on Eclipse SmartHome, we also do work on Eclipse SmartHome. And we also need to maintain, that's why we also need to maintain a separate workspace, a separate PDE workspace, because Eclipse SmartHome is based on PDE. And you have the possibility that you can work on Eclipse SmartHome, build the artifacts, deploy the artifacts in your P2 repo, and then your Bndtools can consume the artifacts from the P2 repos. But this is not seamless. We kind of needed an advanced support so that we can have PDE projects together with Bndtools projects together in one workspace, and Bndtools artifacts can resolve dependencies from PDE artifacts. Thanks to my colleague Jan for having an extension to the project builder that works perfectly in this scenario. Last few seconds, I would like to share some insider tips. Yeah, switching from PDE to Bndtools is a complete change of development model. You just can't tell people to switch to Bndtools all of a sudden, and people will be lost completely. You need to organize trainings, you need to have hackathons so that people get used to it and start working on it properly. Next. Okay, even though you make sure that all the PD projects have been converted to BND compatible projects, doesn't mean that all the test cases that you have previously, they're working fine. You have to make sure that they are also working fine in Eclipse as well as in Gradle. If not, then you have to adapt the test cases to run properly. So this is one of the things that we learned from our mistakes, learned from our past experience. Next, I've already mentioned that we had problems in Bndtools. In Windows, that Bndtools works pretty slower. Raw NTFS is actually pretty fast, but if you use antivirus, then it actually slows down your system writes and system reads 500% slower. So you just have to disable the antivirus scanning in this specified folders, take a, have a look at them, and then it would work. I can bet on this, it would work much faster. Finally, the last one. I really had fun learning BND commands. If you encounter any problems regarding Bndtools, then you can actually debug and analyze the problem pretty easily. Take my word for it. Try to invest some time to learn the BND commands. Life would be a lot easier. So this is pretty much about the presentation. Brings me to the end of my presentation. Don't forget to evaluate it, and don't hesitate to ask any question if you have. But we don't have any time.
We do not have